here we go. When we're doing right triangle trigonometry, we do this thing that you call Sohcahtoa. Okay, and it starts with this idea that if we have a right triangle, so you have to be given a right triangle. If you're not given a right triangle, then your sine, cosine, tangent operations, as we know them, don't work. And every triangle has a hypotenuse. Every right triangle has a hypotenuse. And then the angle, as you can see, theta, is formed by these two sides. So, when we talk about the adjacent side, and some of you already know this, but some of you never really figured this out. Okay? How do we determine the adjacent side? The adjacent side is next to the angle. It helps form the angle. The word adjacent means next to. And so this is adjacent. Many of you are very good at spotting the opposite side. The opposite side is opposite the angle. It's across from the angle. So even though Sohcahtoa is slightly reviewed for you, I want you to know that if you have questions, please ask. There are a number of misconceptions out there among people as they think about what they did and as they try to remember now what to do as they move forward. So people like this acronym, I suppose it's called, because it says that sine is the opposite over the hypotenuse. And the cosine is the adjacent divided by the hypotenuse. And the tangent is the opposite divided by the adjacent. Or, if you're like me, when I first heard Sohcahtoa and said, Sohca what? I said, this is Y because it's your vertical side. This is X because it's your horizontal side. And this is R, or your radius. So I said Y over R, X over R, and Y over X. I always just made sure that my triangle was sitting so that I had a vertical side as being my opposite. That's how I did it. But you can do whatever you want. It's free country. Okay? So you can make your own decisions with mathematics. Cosecant, secant, and cotangent. Never use it with right triangle trig. I can't really think of a situation where you would solve for a right triangle where you would well, this is probably where I would say we start, is that we have hypotenuse divided by opposite, right? Like it's just the reciprocals. But you don't have a cosecant button on your calculator, do you? You only have sine, cosine, and tangent. And so having the three of them is sufficient enough. You definitely don't need the others, because you would just need to take the reciprocal to do the others. Okay, we're going to find the exact value of not 6, but we're going to do 3 trigonometric ratios of the angle theta in the triangle. We're going to do sine of theta. We're going to do cosine of theta. And we will do tangent of theta. Here you can see I have theta. Which side is the hypotenuse? Which side is the opposite side? And we do not know the adjacent side. How will we figure out the adjacent side? Exactly. So the Pythagorean theorem would say that 5 squared plus b squared is equal to 13 squared. Some of you know your Pythagorean triples well enough to say that that is 12. 3, 4, 5 is a Pythagorean triple. So is 7, 24, 25. So is 5, 12, 13. So is 8, 15, 17. There's many of them. We can continue to produce them. Those are the four most commonly used. And then any multiple of those as well. So like, let's say you divided this one in half. You came up with 4. See, 15 divided in half is 7.5. And then 17 divided in half is what? 8.5. So that's a Pythagorean triple as well. Okay. All right, so what's sine? 5/13. Cosine. Tangent? No. You try the next one on your own. Do sine, cosine, and tangent. Okay, as you check out the answers here, you should get sine of theta is 2 roots of 5/5. Cosine is the root of 5/5. And tangent is dos, which is Spanish for 2. Got at least one laugh from the audience. Any questions on those? Going once, twice, thrice, sold. Flip it over. So now we want to solve a right triangle. Actually, just for one part of the right triangle. So we have 9, we have x, we have 42 degrees. Oh my goodness, this looks complicated. I've got this angle here. It's a right triangle. I didn't put that in there, but these are all right triangles. My bad, sorry. It's very hard to do that with the equation editor and drawing shapes that I get with the Microsoft Word. You guys should all complain. Let's just all march out right now. Go down to Gross Close's office. Just start knocking. Oh yeah, that would be great. That'd be great. Yeah. All right. Obviously, x is the hypotenuse. What is 9? That's the opposite. So, are you going to sine, cosine, or tangent? Sine. Sine of 42 degrees is 9/x. I'm going to write sine of 42/1. And I will cross multiply. And I will get 9 is equal to x sine of 42. Then what? Divide. So I have 9 divided by the sine of 42. Now, here's something that's really interesting. What's the sine of 45? You all know that. Yep. Root of 2/2, right? Which is 0.7071. I mean, you guys have memorized those, right? I mean, that was your terminal points worksheet. You did all of them, right? Yeah. Okay, so you know it. You know it. You may not remember it, but you know it. Okay. So if I do sine of 45, no surprises here. I get 0.7071, which is the root of 2/2. But the sine of 42, I had no idea. How did your calculator figure that out? So let's do it. We take 9 and we divide it by the sine of 42. And you do it on your calculator, come up with 13.45. anybody come up with something other than 13.45? Gigi saved you. How did Gigi save you? Yep, and Mo, make sure you're working in degrees, not radians. What is the indication to us that we are working in degrees and not radians? Because it says degrees. Yeah, exactly. So you need to make sure you do that, okay? Sometimes students will kind of say to me, Mr. Gentz, I really don't know when to switch. I don't know how to make it more clear. If you're pressing sine, cosine, or tangent, if it has a degree symbol, you need to be in degrees. If it doesn't, you need to be in radians. Right? That's something you have to be aware of. Okay? Now, you want to know something really bad. You get to the MCA test. Yes, I hope somebody from the state is listening to this, because this is absurd. This makes us lose faith in the exam. This is the calculator you get on the exam. What do you think it's defaulted to? It's defaulted to radians. That's misleading for all students. Figure it out. Man. That angers me. Doesn't that seem misleading? Yeah, darn right it does. Yeah, and then they take away the calculator. Now, to be fair, they also give you a table there that has the values, but anyway. All right. Okay, this one right here. I got 63 degrees, okay? Great. So sine, cosine, or tangent. Cosine of 63 is equal to x over 14. Sorry, I lost control there. I'm very passionate. So x is 14 times the cosine of 63. Well, good thing I got a handy-dandy calculator. 14 cosine of 63. Boom. 636. Does that make sense in context of the problem? Why? It's less than the hypotenuse. It should be less than the hypotenuse, right? The hypotenuse should be the largest side of a 90-degree triangle. You try the last one on your own. Go. Scream. Okay, so I got x is 4.79. We all good? Sweet. Very good. All of these triangles are going to have a 90-degree angle. We'll call all those angles C. Okay? Uppercase C. The capital letters are angles. The lowercase letters are sides. Capital letters are angles. Lowercase letters are sides. B is 32 degrees. If they don't have a 90-degree angle, we don't know how to solve them yet. We would have to then learn the law of sines and the law of cosines. Okay. So first of all, it doesn't matter which one you label A or B. What I chose to do is I chose to have B be the smaller angle because I could tell if this was 32, the other one would be 58. Okay. So we'll get to that in a second. But now what you need to know is that the sides across from the angles are going to be the opposite okay? And they will be the lowercase letters. So here it says C is 8, so this side is 8 because it's opposite angle C. This is angle B, so this is side B. This is angle A, so this is side A. I have my triangle labeled. I have 3 parts of it that I know. I know side or angle B is 32, angle C is 90, kind of, but not 100%. Okay, here we go. So I now want to find the other sides. But first I'll find an angle. It's going to be easy to find angle A, isn't it? What's angle A? How'd you get that? They all add up to 180, and since you have a 90-degree angle, the other two should add up to 90. Very good. So, would you like to find B or A? Okay, everybody wants to find B. We're going to focus on B, and I'm going to use that 32-degree angle. Now, the question is, should I use sine, cosine, or tangent? Sine. Say the sine of 32 degrees is equal to B divided by 8. Cross multiply, B is 8 times the sine of 32. And you guys all know that the sine of 30 is 1/2, so we should be coming up with a value very close to 4, 4.24. How do I find A? Pythagorean theorem, or cosine of 32 is equal to A divided by 8. Most people use the Pythagorean theorem. That's absolutely fine. I'm going to do 8 times the cosine of 32 to get 6.78. Or you could use tangent. Yep. We're all clear? Let's try our last example, and this is a different example. We have angle C is 90 degrees, always. Side A is 5, side B is 12. Thank you, Grace. C is 13. She is the master of Pythagorean triples. Yes, Rowan. I chose to put this side as 5 because it was shorter, and this side is 12. So therefore, A would be opposite side 5. But technically, you could switch them, and your answer should be the same. It's just your drawing will look funny. Okay? All right. What's different about this problem compared to the problem we just did? We're missing the 2 angles. Shoot. Ugh. If only there was a way. If only there was a way. Will, would you like to find angle A or B? Okay. Will wants to find angle A. So, we're going to use Will's advice, and we're going to write sine of angle A is, what would sine of angle A be equal to? 5 over 13, no, yep, so we got 5 over 13. You know the cosine of angle A, you could use cosine instead, couldn't you? What would cosine be? Or you could use tangent. You say tangent of A is 12. Okay, well, we've got 3 options. Doesn't really matter. The point is that you have to understand this next piece. I'm only going to show it to you once. This is why it works. If I have 3x is equal to 21, how do I solve? Or multiply by a third, right? Because that's the inverse operation of multiplication, is to use the reciprocal, correct? What if you had this? What if you had the natural log of x is equal to 4? How would you get rid of natural log? You e each side. Yeah, that's great. Good job. All right. You create a base of e because those are inverse operations, right? Well, if we have sine of angle A is equal to 5 over 13, how do we get rid of sine? We do the inverse operation of each side. And what's going to happen is those will go away and leave you with A equals sine inverse of 5 over 13. So this is a really cool thing. It'll allow us to solve for an angle. So you, instead of pressing sine, you press second sine. And you do 5 divided by 13, and it will come up with your angle, 22.62. And if, instead of using sine, you chose to use cosine, you would then use 12 over 13. And you can see that you're going to come up with the exact same result. And if you chose to use tangent, once again, you come up with the same result. The mathematics that your calculator does to come up with the angle is truly remarkable. It is amazing. Can we now find B? And we take 90 minus 22.62, and we get 67.38. And you can see also how our angles check out. What's our largest angle? What's our largest side? C is our largest angle, and C is our largest side. What's our smallest angle? And what's our smallest side? See how they match up? And that should happen in accordance with the theorem that you used in geometry. All of the problems on the left-hand side will require the use of sine, cosine, or tangent. All of the problems on the right-hand side will require the use of sine inverse, cosine inverse, or tangent inverse. I've divided them up like that for you to be able to work through. Are we clear? There you go.